Okay, this looks good. Yeah, I accidentally started streaming to the wrong key, so we were just doing a template one. All right, well, let's get right into it. Welcome back to OpenGL. Today we're going to be doing another lighting video today. We'll be doing this thing, and then I think a few more lighting concepts, and then we'll be able to move on from lighting. But anyway, we're going to be looking at normal maps today and how they can affect and make lighting more realistic. So as of now, we've looked at normal vectors before, and we define them per vector with our, or per surface rather, because they are included in our vertex. So in our vertex structure we have, let me just find it. Yeah, we have the position, the normal, and then the texture coordinate. So this normal here is uniform for the entire surface. Now this can complicate things, because if we wanted to have a complex model that looks like this, you can, there's a way to solve it with, and that's just by having how many of our triangles, and that's very taxing on a computer, especially for something that looks like this. However, with something called normal mapping, we can kind of influence the way that light reflects off of a surface and kind of create an effective dispersion here. And that's kind of what this means, where you can produce the same sort of mesh with 500 triangles. So that's like 4 magnitudes of 10 underneath 4 million, and if you have a normal map, which is just a single texture. So anyway, what normal mapping is we essentially use we use textures. So we're going to be creating a texture file that looks a little bit like this, and the vertices, their texture coordinates that we already have, that are defined in the objects, in the object file, will map to the texture coordinates here as well. So these two look pretty much identical in terms of their outline and shape, just the color that differs. And with texture maps, we're gonna use the texture values to store the pixels to store values that affect how light reflects off of it, just like we did with the specular map. So with the specular maps, we looked at, I don't know, where's a good one? Yeah, we had our specular PNG here, and that essentially just mapped all the different lighting values to get a per fragment variation on the lighting. So let me just pull up the texture so we can look at it. Right here. Here we go. Alright, so we have our diffuse JPG. The links for these two are down below. And we're just going to create our specular for this so we can incorporate it immediately. So I'm going to create a copy of this, paste it in, and then we'll call it brickwall_specular. What the fuck was that? Alright, I have no clue what that was. Something just... I have no clue. Alright, I'm going to open this up in paint.net. And no, I'm not going to do that. And if you guys remember, the way to make a specular map or something that looks a little like a specular map is just convert it to black and white, and then you can increase the contrast as you want. But I think this is not too bad for a brick wall. Where is it? Here we go, brightness and contrast. Could increase the contrast a bit, but that kind of makes it darker and that won't allow us to see the effects of the normal map as well. You can increase brightness to make it more reflective too. I'll just do that a little bit. You know, that also works too. All right. So that's our specular map. And now let's look at the normal map. Just open the image. So our normal map, you know, why is it so blue? Well, in our specular and diffuse maps, what we did was we stored color values, and that determined the color of the light that reflected off of the fragment. Here, we're going to be storing some information in the color pixels as well, but this time it's going to be the X, Y, and Z components as a float, so from 0 to 1, of the current fragment. So on most of the bricks, it has a positive blue, or a really blue color, so that means that it's the blue component is going to be very large, so that means that the Z component will be large. And that makes sense, because if we're looking at this in our right-handed coordinate system, positive Z points out towards us. So that kind of just relates to that. Now, you see some of these green areas, so that would mean that there's a positive Y or a negative Y in there. And then for the red, that's positive X, and that kind of makes sense over there. So yeah, we're going to look at how this affects it, and we'll look at a few different lights here and how to incorporate this. So let's hop into Visual Studio. Oh, I want to save this. God, Obama's still there. Wow, it's been a while since we've worked with Obama. Alright, so let's go into object.fs. I just want to do a few maintenance things first. So let's see, what is it? Alright, so the first thing I want to do was just delete the use blin and use gamma uniform variables here. I want to remove a bunch of this code. And now that we remove the uniform variables, we can delete the if statement here for the gamma correction and just automatically apply it. Just like that. And then similarly in the calc dir light, calc spotlight, and calc point light, let's remove the fong else statement here. So just delete that entirely, and then remove the if and the curly braces around the blin fong, but we want to still calculate it according to the blin fong. So just like that. And then we'll do that for the point light as well. So once again, we only want to do the blin fong. We don't want to have a switch. And then for the spotlight, just like that. And then the other thing that I wanted to do was make the no texture, so the integer that we have up here, just make it a Boolean, just because we have it. We have the set Boolean function. And then as a result, we can simplify this if statement in the main function to be if no text, rather than no text is equal to 1. And then because we moved some of those variables, we have to go into scene.cpp now, and we will remove a bunch of these here. So let's go into scene.init and just remove all of the lighting variables in the variable log. So use blin, use gamma, and display outline. Just remove all of those. Then also in process input, we can remove these 3 if statements here to determine whether or not to switch the parameters. Let's just delete those. Alright, so that's the cleanup stuff. We have our textures. We looked at our textures. And now let's actually put them into our program. So we're going to create another model here. Or, we're going to create a new item here. And I'm going to name it brickwall.hpp. Alright. In brickwall, we're going to have our macros. So if not defined, brickwall underscore HPP. Define brickwall underscore HPP and if. And then where our brick wall is just going to be a plane, so we're going to inherit from that. So we need to include plane, plane.hpp, and then we're going to call we're going to create the class here. So class brick wall, and it's going to extend from public plane. Then we're going to have a public. We're just going to have our initialization method here. So void init. No parameters, and then we're gonna create a list of textures here. So std vector of textures is equal to, now we're gonna have three textures here: the diffuse, the normal, and the specular. So the first one we'll call texture the constructor. The directory will be assets/textures. The path will be brickwall underscore diffuse.jpg, and then the type will be AI texture type underscore diffuse. Next one will be texture again, same directory, so assets/textures. The name will be brickwall underscore normal.jpg, and then AI texture type underscore normals is the type now. And then texture assets/textures. Then for the specular, it's going to be brickwall underscore specular.jpg, and then the type is going to be AI texture type underscore specular. And then we can end the list. Now we just need to load all three textures. So for texture t in textures, t.load. And then we're going to call plain : init, so the super class method, and we'll pass in textures. And since this is a list, we need to update the parameter in plain.init, since we only pass in one, or we only have the method taking one texture. So this needs to turn into a standard vector of textures. And then we can simply just pass this texture list into the mesh constructor. This soundtrack that we're listening to right now is Fez, the game Fez. Never played it. I actually haven't heard of it, to be honest. But it's by Disasterpeace, and has a lot of the Hyperlight Drifter tunes to it, which is pretty cool. But it does sound pretty similar. But it's still, it has its own unique tune to it, which is cool. All right. All right, let's go into mesh.cpp now, and we're going to find the render method. All right. So at the top, we need to update the setting of no texture first, just as part of the cleanup. So set int no text to set bool no text, and then pass in a true here. And then where we say set int no text 0, make it set bool no text and then false, like so. Alright, so as of now we have a bunch of models, and we haven't really looked at how to do normal mapping for more complex models, like models that actually have normal maps to them. I believe the troll has normal maps to it, and these are going to be more complex because there's a few other things that we have to consider. So because of that, we're gonna assume that not all of the models have a normal map to them. So at the beginning of render, before the if statement, we're gonna say shader dot set bool, and the name will be no normal map rather, and then just set it to true. And then in else, so if we have textures here, you know, I'm just gonna keep this simple for now and put the other textures here, but I think it is possible that we have a normal map with the, or not now. We'll figure that out later. So like the diffuse and specular indices, we're gonna have to keep track of an unsigned integer normal index, which will be equal to 0, and then this will be a case here. So case AI texture type underscore normals, and this is the same type that we initialized our normal map with. Oh, jeez, let me get a sip of water, one sec. That we initialized our normal map with. Jeez, my throat's. I don't know. And then we'll have a similar name format. So name is equal to, and then in quotations, normal plus std2 string normal idx plus plus, and then break. And then what we also have to do is set the boolean to false. So shader dot set bool no normal map to false. The reason why is because we want to tell the compiler or the shader, okay, we do have a normal map, so no normal map should be false. We're just updating this variable up here. All right. Just like that, and you know we're already steaming through this. We can go into main.cpp now, and we're almost there. So we're gonna first include the brick wall. So include graphics / models / brickwall.hpp. Then we're gonna create a global variable here for the brick wall. Alright, so brick wall, and now I'm going to comment out the cube and the sphere for now. Excuse me. Oh, alright. Yeah, so I'm gonna go through this and comment out a bunch of shit that we don't need to look at right now. So I'm going to comment out the registering of the sphere and the cube, and then we need to tell the scene to register the wall as a model. So scene.register model, and then pass in a reference to wall. And then I also want to comment, or I want to change the first light position to be a GLM vec3 at 1.0 and 1.0 and then 0, just so we can actually see it better. And then I want to only render one point light, so the loop here where we initialize each of the point lights, I'm just going to change it from, I goes from 0 to 1, or I goes from 0 to less than 1, so it only renders 1. And then the rest of that stays the same. And then the spotlight, I'm just going to not push back the spotlight. Don't need it, or no, we could actually. Let's take the spotlight and we'll attach it to the camera again. So make sure your spotlight has the camera values here. And then once again, comment out the generation of the cube instances. And then we're going to instantiate the brick wall. So we're going to say scene.generate instance, and the ID will be wall.id. The size will be glm vec3 1.0 float. The mass will be 1.0, doesn't really matter. And then the position we'll say is glm vec3 0.0, 0.0, and then negative 2.0. All right. And we can actually comment out the shadow stuff in the main loop. So pretty much in the main loop, take everything from process input all the way to render the scene normally, and we're just going to comment it all out because I don't want to care about shadows right now. I only want to look at the normal maps. So the removing the launch objects if they're too far, and then also all the shadow rendering. Just comment all that out. And then we're going to render the scene normally, just like that. Now in render scene, since we don't have a sphere or a cube, we need to comment those out. And then we need to add the plane to the render list. So scene.render instances, wall.id, shader, and d2. And then the launch item function, all has to be commented out. Doesn't make a difference. Now in process input, we want to uncomment the spotlight update because we attach it to the camera again. Okay, I think that should be it. I'm gonna run this, and I hope it works. Oh, you know it's not gonna work because we haven't even looked at the shader yet. All right, yeah, this is gonna be okay. Yeah. All right, in object.fs now. Now this is all right. I just completely skipped that. So this is where the magic happens now. So we are going to have our normal map here. So where we have our diffuse and specular samplers, we're going to have another uniform sampler 2D normal 0. And then we will also have a boolean to determine the same boolean name that we set in mesh. So no normal map has to be the same. It's going to be uniform bool no normal map, like that. And then in the main loop, or in the main function, we're going to have our normal here, which is normalized normal, and that's by default. That's if we just want to use the normal value that we get with the vertex. Now we're going to have an if statement here. So if not no normal map, so if there is a normal map, we're going to say norm is equal to texture. Normal 0 is the texture name, and then text coord, same texture coordinates that we use to get the diffuse and specular values, and then .rgb. Remember, because we want to get 3 components here, one for x, one for y, and one for z, and we encode them in the RGB values. Now, the float values go from 0 to 1. However, normals can go from -1 to 1, so we need to map it to that. So the way to do that is just to say norm is equal to normalize norm times 2.0 minus 1.0. Just like that. And then this is the updated normal vector that we're going to use. So we simply just change the normal vector that we're going to pass into the light functions, and we don't need to change anything else. Although for some reason the shadows aren't working for the point lights, the cube map is corrupt or something. So I need to comment out the shadow rendering. I also just want to comment out the directional light. So in pretty much all of the functions, I'm just going to comment out the shadow calculation here. And I'm going to replace it with float shadow is equal to 0.0, so we can just replace it after easily. So do that in the dir light, unless you don't care about this, or if it just works either way. But I'm just going to do that. All right. So now, if we run this, this should work. Believe. Nope. Shadow 380. Oh, I didn't comment it out. Okay, makes sense. All right, so there's our brick wall, and there's our light. See, remember this is we calculate the lighting values for the lamp too, without any emissive shit. So it just looks like there's nothing on there. But that's just a placeholder for our light position. Now here, you can kind of see it, but I'll actually turn up the reflectiveness here. I actually want to increase the size of the window. Haven't done that. I'll make it 1200 by 800, or by 720. So we can increase the light, the point light strength by just increasing the constants here. So I'll make this K1.18 and then K2.064. I'm just going to double them. Oh wait, doesn't increasing... Am I wrong? Or doesn't increasing the... I could swear increasing the light constant actually doesn't work. Here we go. Distance. Yeah, okay, so we want to decrease it actually. So 0.0014. Alright, this should look a little better now. Oh, it's big now. Alright, that looks a little more clear. So you can see the variation here. I'm actually going to have a switch here in a second that we can turn off the normal mapping just so you can see the difference. But you can kind of see how the areas where the brick creases are just not reflecting as much light. Or they are reflecting light, but it's just in a different way. It's in a different direction. So let's go into main. And ooh, this is gonna be weird to do. Let's have another uniform boolean here in object.fs, and I'm just gonna call it uniform bool skip normal mapping. And if then in the main function, if not skip normal mapping and not no normal map, we want to render it using the normal texture. And then we'll have a switch for this in the main loop. So before the loop, I want to set let's say before the main loop, I'm going to activate the shader. And then shader.setBool skip normal mapping true, or false rather. And then in the we can actually make this a let's make this a variable actually. So let's go into scene.cpp, and in scene.init let's put it in the variable log. I forget how to do this. How do you do this? Alright, so scene dot variable log at skip normal mapping is equal to false. And then in scene.processInput, we're going to see if keyboard key glfw key n, we're going to switch it. So what is it? Variable log at skip normal mapping is equal to not, then we're going to get the current value, so variable log at skip normal mapping dot val, and pass in bool as a template argument. Alright, so this should then allow us to toggle it. Alright, so it's on. Oh, because we don't update it in the shader. Alright, that makes sense. So in scene.render shader, we need to replace the set booleans use blend and use gamma with just skip normal mapping. And since we don't have use gamma or use blend, we can just actually cut those out too. Alright, so let's run this now. Alright, like so. I'm going to press N. Okay, you see how that changes, right? I'm pressing N again. And you see how it adds some depth to the thing. Turn it off. And you see how it looks much more flat right now. This is just the diffuse texture here acting. But if I turn on the normal mapping, you see the creases just reflect light more towards the left and the right rather than straight back at you. I actually need to change something here. This should be keyboard key went down because it's a switch. Alright. Yeah. So there's no physical depth, and we're going to get to that in parallax mapping. But you can see how, if you're looking at it from right here, it doesn't, you can't even notice, it looks as if there's physical depth there. But if I turn it off, once again, it looks much flatter. So yeah, that's normal mapping. It's a pretty short video. I just wanted to, I don't know. But the one limitation I will talk about here is how, like I said, with the textures, it's only stored in RGB values, and the default facing for the texture is to be pointed in the positive Z direction. So if we were to rotate this the texture, let's say we were to put the brick wall on the X plane. So let's try and do let's change these a little bit. So instead of being 0.0 in the Z direction, let's make it 0.0 in the X direction. So all you have to do is just swap your zeros in the vertices in plane.hpp, because that's where we define our values for the plane, or for the brick wall. So now this should be on the X plane. So if I look down, I don't know. Oh, here it is. Oh no, that's the light. There it is. Wait, but that's not right. Wait, is that the x-plane? Oh no, I want to do the y-plane, because that'll be more accurate. Or that'll show you more of how this works. Alright, let's run this. Yeah, alright, so that's on the x-plane now. So where's the light? There it is. So you can kind of see it. You see that there is some difference, but it doesn't look as natural. Like, this just seems like there's no reflective property here. Like, right now I should be seeing a reflection because I'm looking pretty much at the reflected ray, but there's nothing if the normal map is on or off. So that's gonna... Oh wait, you know why? That's because the normal value is... Or, you know what? No, that is right. So the reason why is because the normal maps, once again, point in the positive z direction. So there's no distinction. In the next episode, we'll be looking at a correction for that using something called the tangent space, which will allow us to translate the normal vectors into world space, or the other lighting vectors into tangent space, and that'll be interesting to see that. But yeah, anyway, that's a basic introduction into normal mapping. Yeah, and then we'll do tangent spaces next week, and then we'll move on to parallax mapping after that, I think. So until then, let me just... Yeah, alright. Until next time, enjoy yourselves. Make sure you invest in GameStop. That's a big thing. Do that, please. But you can't do it on Robinhood anymore. Yeah, keep yourself safe. Don't get in trouble with the SEC. And I'll see you guys next time. Have a good one.